So my name is Ian Opperman. I'm the New South Wales Government Chief Data Scientist, but also an industry professor at the University of Technology, Sydney. It's a really exciting time to be in data and AI, in particular in government. And I think we have a lot to thank ChatGPT for that. It's as if AI has just happened. It's as if we've never done anything in this space before. And one of the things that we're reminding people is, first of all, the sky's not falling. AI is not magic. It is a data-driven tool. And we do have frameworks, and we actually have in New South Wales the AI Assurance Framework, which tries to connect the principles of AI to the doing of AI. So the principles to the bits, the risk frameworks to the algorithms. And so part of what we've been trying to do is reground the conversation, but increasingly give people tools that help them think their way into appropriate use, give people tools to think about appropriate use of data, give people tools to think about what are the minimum standards I need in order to appropriately and safely use AI. So the exciting stuff is actually helping people see that this stuff already exists. It's not actually magic, but once you reground the conversation, you can do some pretty powerful stuff. So the problems we care most about in government are really those wicked challenges, the complex, subtle problems that have persisted for a long time. We're getting better and better at using AI to automate things. We're getting better and better at using AI to scale things, but it's still understanding those wicked challenges, which really is where the real benefit will come. There are problems which affect all of society. We know about climate change, and that's a big issue that Australia is responding to. But we've got issues around ageing. The whole population is aging, and thinking about aging from an integrated perspective, being customer-centric about aging, is actually a really big mental shift and requires a lot of thinking about government as an employer, government as a service provider to a population which is aging. We've got some other challenges around the transformation to net zero, another really, really big challenge. And the complexities of dealing with the energy generation, distribution, consumption, considering that it's no longer one-way flow of energy to load points. We're now talking about prosumers in a network who generate and consume both energy and data. It creates so much complexity in a system which is so fundamental to what we do. Again, data has a very substantial role to play in helping us understand, but also AI has a very important role to help us not only make sense of, but also increasingly optimize locally. So we're getting better at embracing big challenges, but it's a big challenge comes with lots of complexity, lots of moving parts, lots of partnerships, and lots of ways that we really need to understand the problem differently. I think people have acknowledged that the simple stuff has largely been done, and the problems we really care about are those big, complex challenges. And so what's exciting is that we're starting to have conversations around what do we want to achieve as opposed to what can we do? What's the outcome we're looking to achieve? And there are a set of outcomes which are in the UN Sustainable Development Goals, 16 outcomes that say we want the world to look like this by 2030. Australia has signed up to the UN Sustainable Development Goals, many other countries have. It's good because what it says is we want the world to look like this, and when we take that same translation to it's a smart city, or it's safe, affordable, reliable energy, or it's an end of poverty, or it's quality education, we describe the world in principles that we can debate, we can discuss, and we can ultimately agree on. The trick then is measuring it, understanding how we get there, understanding that journey of child, family, household, community, business, and then identifying those points of friction which take us towards or away from the goals we're trying to achieve. So we're getting better at embracing complexity. It's still hard, it's still bold, and it still requires you to think years and years ahead as opposed to the very short term. But we've been demonstrating that we can do it, we can describe the world in terms of those outcomes, and that we are making progress as to how we think our way into these really complex problems. That's a great question. We ran an event last year in New South Wales called Future.NSW, and we looked at 2030, 2050, 2100, and even contemplated the 22nd century. A child born today is very likely to live to be 100 years old. They will make it to the end of the century. They will make it to 21, 23, very likely. And so we asked a whole range of questions about what it looks like for that child from education, from a defence, from a work perspective. And we very quickly run out of ideas, we very quickly run out of imagination. But one question we asked everybody is, when do we stop talking about data? When have we sorted this out? And opinions varied, but it was around 2050, which we all believe will have it sorted by 2050, and let's see whether we actually do. It's still a pretty mercurial concept. Data is still a little bit like dealing with fog, a little bit like dealing with smoke, and we don't yet have those safety standards for dealing with it, but I'm pretty sure by 2050 we will. I'm hoping we have it a lot sooner than that. But just like electricity, we've seen it move from turning engines and running lights to doing pretty much everything in our society, everything. The camera, my watch, my mobile phone are all running on electricity, very different to the way it was originally conceived. I think data and AI will be as pervasive and as present everywhere in our lives to the point where it disappears. And hopefully it disappears safely and it disappears in a way that we can really benefit from it. But we've got a way to go to get to the point where it works that well. ChatGPT in particular really lit people up towards the end of last year and the beginning of this year. And it really does seem like people are seeing it for the first time. They're seeing AI for the first time. Many people have a digital assistant, many people have a Google or an Alexa to talk to. But the number of times that the assistants will come back with, I don't know, but I found this on the internet, is many. Now what we're seeing is some things that look quite credible. And part of what we need to do is remember that what we're dealing with is an algorithm running on data, and that data is noisy, and that data is imperfect, and the algorithms can produce some interesting results. Hallucination is a word we're talking about with these generative AI models, and there's no other tool that we would reasonably use that would hallucinate. Imagine your ruler or your calculator was hallucinating. So partly it tells us that we need to rethink about how we use essentially unreliable tools, or tools that we can't scrutinize with great clarity, that the transparency is just not there in one of these tools. Partly we need to remember that whatever we put into it goes into a different domain, so there are privacy and security issues. And partly we need to remember that if we can't explain it and if we can't verify it, then we can only use it for a really limited number of purposes. So the AI is a little bit like all the stuff that we can do with electricity these days. We can run all sorts of different applications. But way back when we first started using electricity, we were not only making motors and lights spin, but it was somewhat of a parlor game. And you could do some pretty interesting, surprising things with electricity. I think we're still at that phase with AI. We haven't quite worked out how much we can trust it and what the frameworks are that normal people can really apply to understand intuitively, this is how much I can use it, this is how much I can trust it. I'm not going to use it for air traffic control, especially if it's hallucinating, but I might well use it to write me a haiku. Quantum is really interesting. It's a little further down the track in terms of the ability to have wide application. What's really changed with AI is moving from narrow application to quite a lot wider application. But quantum's already on the scene, and quantum standardization is already something that Australia is taking very seriously. And by the time we start talking about standards, we're talking about issues of interoperability, issues of engineering. So it's moving from the R-only phase to the R&D phase, and of course as it develops more, we'll increasingly see it applied. So I think quantum really is going to equally surprise us in terms of all of a sudden, when it's finally good enough, everything changes. And when everything changes, it means that our security systems need to be rethought, how we do online transactions need to be rethought, our communication systems need to be rethought. So it's at the moment a problem in the horizon, but it's a problem which I think will hit us pretty quickly if we don't keep focusing on it. A few other things. I still am a great believer in blockchain technology outside of cryptocurrencies. Move that clearly to one side. I think there's a great potential if we can get the price down, if we can get the throughput rates up, and if we can get the reliability up so that anyone can run it on any device. I think there's real value to be had there. And I think digital twins are also going to increasingly surprise us when they stop being just simple models of building information model, it's been very valuable and it's been great in manufacturing, it's been great in construction. But as we start to connect other systems and processes to those digital twins, when we start to connect legal elements to it, when we start to think about provenance, when we start to think about the systems and processes of real life, joined in that way, looking a little bit like a metaverse, I think we'll again be quite surprised by just how powerful those digital representations of real world systems will be. So predictive capabilities were the great promise of AI and machine learning years ago. And if we were having the same conversation 7 years ago or 8 years ago, we might have used exactly the same words. We just understand it a whole lot better now, and we understand when it really matters, we really need to take care. So I think one way to describe it is that complex problems have an element of predictability, wicked problems don't. Wicked problems really resist prediction because there are so many different factors. But the more we can apply predictive capability to increasingly smaller components of those big problems, increasingly I think we're going to find more and more value out of the analytics that we've been trialing over many years. We also are starting to get better at putting the guardrails in place. This is how much we need to control this environment, and this is the limit on how we can use the result, versus something which is increasingly less consequential, and therefore we can be broader in terms of who accesses it for what purpose, and what we put in terms of restrictions or prohibitions or guidance around the data products that we create. So it has a while to go, but I think we're getting better at understanding what we've got. We're getting better at understanding data. We're getting better at understanding what algorithms do to data. And we're getting better at understanding the difference between an interesting result and the consequences it has in the real world. So we've got a little way to go, but we are getting better. One of the things that I have noticed over the years is lots of people talk about data sharing frameworks, and they've got a great idea and they're reframing the conversations in terms of outcomes, and then they sit down and say, let's design a data sharing framework. During the course of the last 5 or 6 years working with standards and working with the Australian Computer Society, trying to come up with these data sharing recipes, I realised that the problem is not only complex, but it's actually infinitely complex in a couple of different dimensions. Every data set is unique. Any data set can be used for any purpose. Context changes everything. Once you generate a data product, it's unique. It can be used in almost any different way, and context changes everything. So you've got at least 6 degrees of infinite to deal with. So it's no wonder we've really struggled with this data sharing in a general sense, and we've led to some pretty black and white behaviours. It's either totally locked down or it's totally open. Acknowledging your context, your sensitivity, your environment is unique and your use is unique, we can actually start to identify those areas which are repeatable. And so we're getting better at identifying the repeatable patterns of use and acknowledging the infinitely complex or infinitely variable of a particular circumstance. That may sound like not a big step forward, but if we can say these ones are repeatable, we really just need to focus on these. We're starting to narrow down into those areas that we need to make judgment, those areas that we need to limit the different possibility of context, and we can start to say, I'm going to constrain my environment just enough for this to be useful and for it to be safe to be used. And that's really been a big step forward. And it surprised me when you start to get your arms around this really complex, subtle, mercurial problem and realize what it is you're dealing with. I think we're right on the cusp of being able to do that. And the more we can use these tools, these repeatable patterns of use, the more we'll generate real value from data appropriately and safely. We've got a long way to go. I think we really are just at the next inflection point. And if we had the same conversation in 2 years' time, we'd be so far up that inflection point, we'd look back and say, well, we were only just at the beginning way back then.